Okay, so math 2, 9-5, proportions and triangles. Your objective is to use the side splitter theorem and the triangle mid-segment theorem to find the lengths of sides and segments of triangles. Use the triangle angle bisector theorem to find lengths of sides and segments of triangles. So the side splitter theorem states if you have a triangle and you have the mid segment parallel to the base of the triangle, turns out that the lengths that make that triangle, the side lengths are actually proportional to each other. So AM is proportional to MB, and then NC is proportional to NB. Another way you could also think about it this way is if you break the triangles and if you separate the triangles. So if you do it this way, it's honestly the same thing we did yesterday. So we have MB and then BN, and then you draw the bigger triangle because it's one triangle on top of the other. Turns out they are proportional to each other. So BA and BC. So that's technically what it means. So if you get something like this, just break it apart and then just write the proportions. And then the only thing that's added is that the fact that the base sides are parallel, meaning they'll never touch. So that's the side splitter theorem. The triangle mid-segment theorem is that if the side lengths are proportional, so DG is proportional to GE, and then FH and EH are actually congruent. Turns out that these base sides of the two separate triangles are congruent. And then the relationship between this segment and this segment is it's actually half of the larger segment. So that just means if this is 10, GH is actually 5. So that's the triangle mid-segment theorem. So whatever the length of the base is, the mid-segment is half of whatever the larger segment is. But this only works if this segment is halfway between the long segment of these two separate segments. So remember, this is midpoint. It cuts the side lengths perfectly in half. The last one, the triangle angle bisector theorem states that if the angle UVX is congruent to WVX, then the base sides, so this side, UX is proportional to WX, and then UV is proportional to VW. So it'll make more sense once we do practice problems, but that's pretty much the three theorems that we're going to focus on today. So number one on the other at the OSFC page says write a proportion that can be used to find the value of x. This one doesn't say us to solve. For number one, it's just asking you to write the proportion. It's not actually asking you to solve. So for the number one, you're just going to be looking at theorem 9-7 angle bisector, which means the base sides are proportional and the adjacent sides of that angle are also proportional. So how are we going to write that? X is going to be proportional to 15 is equal to 11 proportional to 12. And that's pretty much it. Or you could have also written it. So there's two answers you could have also write it as. You could write 15 is proportional to x. And then 12 is also proportional to 11. So either one of these two answers is correct. So there's more than one right answer of writing the proportions. Does anyone have any questions for number one? So you're not solving it, it's just asking you to write the proportion. Okay. For numbers 2 and 3, this one's asking you to solve. So it's the same thing. If it helps, just redraw the picture, but you don't necessarily have to. But in this case, I'll just redraw it. So that's the small one, x plus 7. This is 12. And then the big one, This would be 2x plus 7, and then 8 plus 12 is 20. And then you could just write the proportion x plus 7 over 2x plus 7 is equal to 12 over 20. Does anyone have any questions so far? I just broke the two triangles apart. This is the small triangle x plus 7 and 12, but then this whole length is the sum of x and x plus 7. So that's how I got 2x. And then I got 20 because this is 12 plus 8. So this whole length is 20. So let me 2x plus 7. And then this right here is 20 for the large length. And then just like yesterday, cross multiply. So we will have 20 times x plus 7 equals 12 times 2x plus 7. And then distribute 20 times x is 20x times 7 is 140. 12 times 2 is 24. 12 times 7 is 84. Subtract 24x to both sides. You're left with negative 4x. Minus 140. Negative 4x equals, and then this cancels, this cancels. Let's see, 140 minus 84. Negative 56 divided by negative 4. X equals, is that 9? No. 56 divided by 4. 14, thank you. All right, x equals 14, and that is your answer. Let me zoom in a little bit, sorry. For this one, you could have also used the side square theorem, which we'll use in the next problem. Okay. For number 4, this one you're going to use the side splitter theorem. Which states either you could write 4 is proportional to 7 or 7 to proportional to 4, whichever one is perfectly fine. In this case, I'm going to do 4 proportional to 7. So 4 proportional to 7 is equal to x proportional, which makes this one a little bit tricky because you got to figure out what that little portion of the segment is. So here's the thing. This whole thing is 8. This little segment here is x. So that means I can actually write an equation for this little segment, which is actually 8 minus x, right? Because if I wanted to figure out what this segment was, all I would have to do is get 8 and subtract it by x. Unfortunately, we do not know what x is, but we can just write what it's equal to, which is 8 minus x. So that's kind of the little extra part you actually have to figure out yourself, is that that little segment is equivalent to 8 minus x. And then you just cross multiply. 4 times 8 minus x equals 7 times x. 4 times 8 is 32. 4 times x is negative 4x, and then that's just 7x. Add 4 to both sides. Thirty-two is equal to 7 plus 4, which is that 11? Divide by 11. X is equal to 32 over 11, or I did not write out what it wants you to write it, but 32 divided by 11 will give you 2.91. So if it's asking you to write it as a fraction, you leave it as 32 or 11, or if it's asking you to write it as a decimal, then you could just write 2.91. Any questions on number 4? Number 5 is pretty straightforward. It's a side splitter theorem again. It's saying that QL is to PM. So QL is right here, and it's equivalent to PM. So then if you want to find SQ, that would be equivalent to JP. Or is that RP? No, that's JP. So this would be JP. Does anyone have any questions on number 5? Sorry. For number 6, for this one, we'll just use the side splitter theorem, but you could do the triangle thing we did for the other previous problem if you want, but you could also use the side splitter theorem. So that means 7x is equivalent proportional to 20. 8x is proportional to 5x plus 5. Or you could do the whole triangle thing. That's perfectly fine too. So there's 2 ways of doing this. Cross multiply 7x times 5x plus 5 equals 20 times 8x minus 3. Distribute 35x squared plus 35x. 160x minus 60. So subtract 160. Oh no, this one's actually kind of hard. 35 minus 160. Negative 125x equals negative 160. Should I have done it this way, or should I just done the other triangle? I think we'll end up either way. So let's see, 8x minus 3, 5x plus 5, 7x 20. And I'm double checking my math to make sure I did this, multiplied everything. 7 times 5 is 35. 20 times 8 is 160. 3 times, nope, everything looks pretty good. This is just a long one. 35x squared minus 125x plus 60 is equal to 0. So we're adding 60 to both sides. Now I can see why this problem. Okay. So remember, anytime you're trying to factor a quadratic equation, you have to find the GCF. So there's a value that goes into 35, 125, and 60. I believe the only number would be 5. Because, yeah, 5 is the only number. So GCF. So GCF is 5. So if I factor out 5, I'll be left with 7x squared divided by 5 minus 25 plus 12. Well, 25x. All right, here comes the hard part. So I gotta figure out two numbers that multiply to 7 times 12, which is 7 times 12, 84, but adds to negative 25. So this is the one where we're gonna have to use our brains. Two numbers that multiply to 84, but has the sum of negative 25. Let me double check to see if this is correct. No, everything seems pretty good. Thought this one didn't have a square. Oh, I guess it did. Okay. All right, so we're gonna write the factors of 84. That's honestly the best thing to do. So we have 1 and 84, 2 and 4 divided by 2 is 42. Divided by 3. 3 and 28. But fortunately, this doesn't work either.
There's 4 and 21.
Ah, you're right. 4 and 21. Thank you. Yes, we actually had to go one more. So negative 4, negative 21. Negative 4 times negative 21 is 84, and then negative 4 plus negative 21 is negative 25. Yeah. So then we're gonna write negative 4, negative 21. But remember, since we multiplied by 7 to the last term, we have to divide each term by that value. So divide by 7. Negative 4 over 7 does not simplify, but negative 21 over 7 simplifies to negative 3. So when we write out the factors, it would be 5, 7x minus 4, x minus 3, because there's an imaginary 1 on the bottom of that negative 3. So that would go right in front of this x. So we will have equals 0. So we're going to have two answers for this problem. 7x minus 4 is equal to 0. X minus 3 equals 0. And then all we're doing is just solving for x. 7x equals positive 4. Divide by 7. X equals 4 over 7. And x equals 3. So you have two possible solutions. Number 6. And let me double check. Does anyone have any questions? I'll give you guys a moment to write it down. This was number 6. Okay, so this one, this has two answers. So when you do it on Savas, just make sure you put the comma because it's asking you to write both of them and then just separate them by a comma. So instead of writing and, just put a comma and leave it as a fraction because if you write it as a decimal, it's going to tell you it's incorrect. Okay, number 7, we're going to use the last theorem. So 5x is proportional to 11x minus 2. Oops. And then 3x is proportional to 4x. And then we just got 2 more, then we're done. Cross multiply. 5x times 4x is equal to 3x parentheses 11x minus 2. Anytime you multiply a monomial by a binomial, I will always recommend you write the parentheses. So we will have 20x squared, 33x squared minus 6x. I'll subtract 20x squared to both sides. Zero equals 13x squared minus 6x. And then you just have to factor the GCF is x. Right? So if I factor out an x, I'll be left with x parentheses 13x minus 6. The greatest common factor is x. So then I factor out x or divided each of the terms by x. So now I set them equal to 0. X equals 0 and 13x minus 6 is equal to 0. So we have one answer because that's already 0. But for the other one, you have to add 6 to both sides. 13x equals 6 divided by 13. X equals 6 over 13. So that's the other answer. So you have two answers. 0 and 6 over 13. Actually, no, x cannot equal 0. The reason why x cannot equal 0, because this is a mistake I made in the other previous problem. Because if you plug in x equals 0 in the line segment in the figure, a length cannot be 0 or negative. So that was two things. So that's why the only answer for this is only x equals 6 over 13. This one is not possible. So you have to be very careful. On x equals 0 is not a possible solution. It can only be 6 over 13. The previous problem, this was fine because they were both positive. And I think even if you plug 4 over 7 into x minus 3, you still end up getting a positive number. 8 times 4 divided by 7. Yeah. Yeah. Even if you plug 4/7 into x minus 8x minus 3, it will still end up becoming positive. So it's perfectly fine. Does anyone have any questions with number 7? All right, last problem, number 8. So this one seems kind of tricky, but it's actually pretty straightforward. The only thing you're missing in order for you to solve for x is this length right here, because you can't write the proportion of x is equal to 8 and 5 is equal to blank. So you actually need to figure out what this missing length is. So we're gonna put a variable y. And it turns out we can write proportions. We're gonna use the side splitter theorem. 5 is proportional to 3 and y is proportional to 5. So 5 is proportional to 3 and y is proportional to 5. Or technically, you can just write it as st if you want. So you can find that length. I just put y because it's just one letter instead of writing the length segment st. But you could have written that as well. Cross multiply. 5 times 5 is 25. And 3 times y is 3y. Divide by 3. So y is equal to 25 thirds. It wants you to write as an improper fraction, so we gotta keep the 25 thirds. Do not write it as a decimal, because then you're not gonna be able to get the answer correctly at the very end. Does anyone have any questions so far? Because that's the hard part. Okay, so we figured out this is 25 thirds. Now we can write the proportion of x is to 8, right? Because that's what 3 plus 5 is. So x is proportional to 8. And then 5 is proportional to 25 thirds. Before we do cross multiplication, you kind of have to simplify this fraction here. Does anyone remember what happens? What do you do when you divide by a fraction? We learned it in 8th grade. How do you simplify division with fractions? Anyone remember? You do KFC, keep, flip, change. You keep the 5. So another way you can write this is 5 divided by 25 thirds, right? Because that's what the division is. KFC or keep, flip, change is you keep the 5, you flip the fraction. Well, now it's 3/25, and you change from division to multiplication. So now it's 5 times 3/25. And all you have to do is just multiply across. Technically, you should simplify first, but we'll just multiply across. So that 5 times 3 is 15. 1 times 25 is 25, but these are both divisible by 5. So this simplifies to 3/5. So now we have x over 8 is equivalent to 3/5, because 5 over 25 thirds is the same as 3/5. Now we do it that way, so now it's a lot easier to cross multiply, because technically you can still cross multiply this, which I mean, I guess it wouldn't be too bad, but actually, no, actually, if you cross multiply, I think you still get the answer. Yeah, okay. All right, then cross multiply. 5 times x is 5x. 3 times 8 is 24. Divided by 5. X is 24/5. And that would be the answer that you would put in to Subloss. Actually, could you do this without simplifying the fraction? Let me try it. Let me see if you get the same answer either way. So let's see. You don't have to do this. Is anyone still writing this one down? Because I think it still works if you do cross multiplication with a fraction and division. So let's try it. I'm gonna try it and see if we still get the answer. So let's see. X over 8 is equal to 5 over 25 thirds. Cross multiply. So X times 25 thirds is equal to 8 times 5, which is 40. This would be 25x divided by 3. Cross multiply again. 25x, 3 times 4 is 120. Divided by 25. X is 120 over 25. And then both of these are divisible by 5, right? Is there a bigger number that goes into it? 25, nope, 20, 25. We'll see, we'll go by 5. So let's see, 120 divided by 5 is 24. 25 divided by 5 is 5. So is that 20? Is that the same answer? Hey, look at that. We still get the same answer. I wonder if I should teach this to the other class, but doing it this way, key flip change will get you to technically the right way of doing it. But all right, that's it. That is the end of the lesson. I'll have your homework posted up on Canvas